Now, the Therac 25 example might feel distant for some of you. And not all of us, certainly very few of us, will end up working on medical machinery. So let's talk about something that's maybe a little closer to home and talk about government censorship and surveillance, especially because over the last 5 to 10 years, it's been in the news quite often. And I also know many of you are interested in working on cybersecurity. So you'll learn about encryption and cybersecurity, but I'll talk about it briefly. The very original messages that were being sent on the internet back and forth were just in plain text. So they're very easy to see. Anyone who was listening, it's just like if you say something in a room, you and your friend are in a room together and someone overhears you, they can understand. Well, early on in history, and you actually know this from this class, the Caesar cipher, to pass along war messages, a general or communicating with majors or whoever in the army would need to figure out some way to pass along commands or instructions without the opponent or the enemy being able to understand what they say. And thus the whole domain of cryptography and encryption was born. Now, our modern day cryptography that we have for the internet is strong enough that it can't be broken by anyone. And so when you go to a site and you see this little lock in the top left corner, you can see here it says connection is secure. And in fact, if we could even pull up and see exactly how secure it is, or what protocol it's using, what kind of encryption it's using to secure your connection to Google. But anything that's properly encrypted, it's impossible for communications to be read, altered, or modified. And that's based on some assumptions on how fast our computers are today. Nothing is impossible to break into, but the math behind this encryption makes it so that it would take thousands of years or many, many tens of millions of dollars to decrypt something, because the math uses kind of a random number that you can't guess, and it would be so expensive to try every possible number. None of us were around in this class around in the 90s, but there were intense debates on whether or not to regulate cryptography, and ultimately no regulation is introduced. And today, all of our connections, many of our connections on the internet, are HTTPS, which is a secure connection that uses cryptography. Now, you might remember when Edward Snowden leaked some information about the NSA. It was a whistleblower that shared that the NSA was secretly recording and tracking many communications between people in the United States. And so in 2014, Apple made iOS 8 use encryption so that without entering a passcode, it was impossible to see the actual contents of memory on the phone. So no one could actually see them. It's not like just a lock on the outside of a door where if you get in through a different side without going through the lock, you can still get the stuff from inside the house. This actually takes all of the items that are locked up and scrambles them so that they're unreadable. So even if someone could look inside the room that's locked, you can't actually tell what's in there unless you have the passcode. Now, see if you can think of any problems with this. Well, the FBI had this scenario on its hands. 14 people were killed, 22 were injured by a man who owned this phone. This was in 2015, at the end of 2015. And imagine you're the government, and you have a chance to figure out why this person killed so many people or injured people. And if it was a terrorist attack, figure out who instructed this attack to happen. And so the government ordered Apple to come up with a way to bypass that security, that encryption. Apple promptly refused and said that they wouldn't do it, and took a strong stance on privacy and saying that the good of unlocking this one person's phone does not outweigh the bad of being able to unlock anyone's phone, and so infringing on people's right to privacy. So they wrote this in their letter. Building a version of iOS that bypasses security in this way would undeniably create a backdoor. And while the government may argue that its use would be limited to this case, there is no way to guarantee such control. So they were saying that if we make a way to get into any phone without the passcode and decrypt what's there, even though you're asking for it to be used just this one time, it'll very likely, we can't control it once it's out there. And so it can be used on many different people, and then it's as if there's no encryption if this tool exists. In the end, a month later, the FBI did actually find a way to break in with a third-party tool, because the implementation of this cryptography wasn't perfect. In this case, was withdrawn. But for using this tool, it cost them more than $1.3 million to get into the phone. But it was still breakable. Just an interesting fact is, what did the FBI actually find? Ultimately, nothing. Ultimately, they acted alone. No information was found. And so it was all a moot point. But this brings up a question here. What do you think? Do you think that Apple should have complied with the court order to try to figure out what the motivation was behind the attack, or figure out if anyone helped them, or maybe there's a group chat where they were discussing with other people some other attack that was going to happen? We'll talk about this in class. But fundamentally, there is some trade-off between individual freedoms, which are infringed upon by being able to unencrypt data that you don't authorize to be unencrypted, or by kind of observation and data collecting, and societal safety, where knowing that things can happen, how do you find out that some big bad event is going to happen, or figure out why it happened, or who helped enable it to happen? Now, I wanted to add, Apple has recently been back in the news earlier this year. Apple implemented a way to scan US iPhones for images of child pornography. And this created a big discussion on what Apple's stance is on privacy. Because in the last scenario like this, Apple stood up and said that where they're not going to decrypt a phone, even if it kind of makes sense for this particular case, to support people's privacy. Whereas in this case, for this scenario, Apple decided to implement an algorithm that would scan users' photos and see if they look like child pornography. And if so, report that child pornography to the authorities. And so on one hand, you had some people saying, yes, we should fight child pornography with any means that we have. And on the other hand, we had people saying that scanning people's photos without approval, even for something that is universally agreed upon to be bad, and we do want to get rid of child pornography, who's to then stop Apple from scanning for something else? Like political dissidents or human rights activists, and find their communications or their photos and report them to the authorities if the authorities decide to use that. So this is something we'll also discuss in class.